Hi there, welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be learning about metals, non-metals, and alloys for GCSE chemistry. Let's get started. So, metals can be found in the Earth's crust as a metal ore, and this is a finite resource, meaning that it doesn't have the ability to be made again in our lifetime. So, once we extract these metals from the Earth using mining techniques, we can actually further extract the metals using bioleaching, phytomining, and even electrolysis, depending on the type of metal. And I will do a video about these techniques in the future. The majority of elements we know about in the periodic table are actually metals, and they're found towards the left hand side of the periodic table. And they're organized in this way because of their physical and chemical properties. So, all metals have a lustrous shine, they are malleable, meaning they can be bended or molded into specific shapes without cracking. They are ductile, which means they can be drawn into wires. They are also very good conductors of heat and electricity. This is also true in metals that they use metallic bonding and they form positively charged ions. Non-metals are also found all around us in the world around us. So you could think of oxygen as a non-metal, carbon as a non-metal, hydrogen, helium, hence the balloons. They are found towards the right-hand side of the periodic table. And if you want to learn more about the periodic table, feel free to check out my video on my channel about it. I'll link it in the cards above. All nonmetals have the same physical and chemical properties, so they are dull, they have low melting points, they are poor conductors of electricity and heat, they have low density and are often very brittle. The chemical properties include covalent bonding, they form negatively charged ions as well. So if we look at the atoms of an metal atom and a non-metal atom, you will see the difference here. So metal atoms are able to donate electrons, and this is because they have a delocalized electron structure, meaning that the electrons are able to move around in that structural form. So a lot of the metals you see have a giant metallic structure, and there's a sea of electrons which are delocalized and able to flow. This is why, by the way, metals can actually conduct electricity because of that movement of electrons, that charge, that current, I should say. So, because they can donate electrons, they lose that negative charge, they form positive ions, and those electrons are accepted by the non-metal atom, and those non-metal atoms will form negative ions. And the reason these electrons are able to be donated and accepted is to ensure the atom is stable and the full outer shell has been complete. Worth mentioning at this point is the term alloy. It's a mixture of two or more elements where at least one of the elements is a metal. And one of the examples you need to know at GCSE is steel. So, like I mentioned before, some metals are magnetic. Steel is a magnetic material, and that is because it contains iron. Iron is a ferrous metal. Essentially, what that means is it is magnetic. Pure metals, worth mentioning at this point, all contain or have a giant metallic structure. And like I said, there will be lots of delocalized electrons within this structure. The atoms, because they are all arranged in layers and they are all uniform in size, they can actually move over one another. Those layers can move across one another with very little force. And this means that those pure metals are very soft. So if you look at the structure of sodium metal, for example, you can cut these metals with a butter knife. And when you look at the required practical in chemistry, where you check the reactivity of metals in the group one, you can actually see you can cut those metals with with a butter knife, really, and they're very very soft. Um, but because of this, those pure metals are often not utilized in everyday objects because they would bend and they would not be helpful to us. So often we have to mix these pure metals with another element or another metal, and this actually increases the hard wearing nature of that object. So we call these alloys. So, for example, steel, we use steel in industry or in everyday objects because it's very hard wearing. And at an atomic level, you can see that the atoms in an alloy, they're all slightly ununiform. They're not the same shape. And that means that those layers have been distorted so they don't flow over each other as easily. You actually have to increase the force applied to move them as much as you would have had to do in the pure metal. And that means they're a lot more hard wearing and therefore more useful to us. I hope you found that video helpful. I've been the GCSE science teacher and you have been curious. If you did like it, feel free to like, comment, subscribe, and share with someone that you think would also find it helpful. If you want more GCSE content, check out my channel or also find me on Instagram and TikTok now at the GCSE science teacher. And until next time, I'll see you soon. Have a good day. Bye.